Hey there, it's William. Today we're going to figure out why a Samsung dryer is only producing low heat when the high heat setting is selected. This problem is often caused by a faulty thermistor, heating element, or main PCB. Now before we jump in, make sure to like this video and subscribe to our channel to see more expert repair guides. With over 2 million products in stock and the know-how to help you do it yourself, we are AppliancePartsPros.com. First, we're going to grab a few tools. Today we'll need a Phillips screwdriver and a multimeter. Also, please remember that safety comes first. Always disconnect your dryer by unplugging it or switching the breaker off before doing any kind of work on it. Our first check is the thermistor, and to get to it, we're using our Phillips screwdriver to remove the 2 screws that hold the top panel at the back. Then we're moving the top panel to the back, lifting it up, and setting it to the side. With that out of the way, we're using our Phillips screwdriver to remove the 3 mounting screws that hold the main control housing to the front and side frame. Then we can carefully rotate the main control so that we can get access to the wires and make sure no bare wires are touching any metal. We need to find the connection CN4 and disconnect the wires. After that, we're grabbing our meter and setting it to resistance, which looks like an upside down horseshoe. Then we can test from the blue wire to the red wire. There should be a resistance reading of around 10K ohms or 10,000 ohms at a room temperature of 77 degrees. If the thermistor reads much different, which is anything outside of the 10% range, then the thermistor would need to be replaced. If the resistance is within that 10% range, then we'll need to continue troubleshooting. To check the heating element, now we're lifting up on the console and pulling it away from the dryer. We're disconnecting the wires behind the console on the right. Then we can lift up on the console and setting the console to the side. Now we're going to use our Phillips screwdriver to remove the 2 screws behind the door in front of the lint trap and the lint filter. We also need to remove the 4 screws at the top of the panel. Then we can slightly lift the front panel up and rotate it forward. Once we've done that, we can disconnect the door switch harness and completely remove the front panel. You can just set the front panel to the side for now. Now we're unlatching the wire retainers from the wire harness. Then we can use our Phillips screwdriver to remove the 5 Phillips screws from the top plate and set it to the side as well.
We also need to disconnect the wire from the drum lamp.
We're also removing the screws from the lint duct, pulling the duct down and setting it to the side. Next, we're removing the 4 Phillips screws from the front bulkhead and disconnecting the sensor bar wire connector. Now we can lift the front bulkhead up and pull it forward. At this point, we can reach back and remove the belt from the idler pulley. Once that's done, we can remove the drum and belt and set them to the side. We're setting our meter to resistance, which looks like an upside down horseshoe, and testing the heating element for resistance with 1 wire removed from the element terminals. We should get a resistance reading of 10 ohms here. If the resistance shows open or OL, then the element has failed and would need to be replaced. If you've reached this point, then the main PCB would be the cause of failure. We've already verified this through the process of elimination, so I'll show you how to replace it in case yours is faulty. We're going to install the drum and belt and secure the belt to the motor and idler pulley. Then we can grab the front bulkhead, install it, and secure it with the Phillips head screws that we removed earlier. We're also reconnecting the sensor bar wires. Next, we're installing the lint filter housing. We're also going to go ahead and install that lint filter. We need to connect the drum lamp wires and then install the top plate before we secure the wire harness with the retainers. At this point, we can grab the front panel and guide it onto the bottom hinges, connect the door switch wires, and rotate it into place. Then it can be secured with the screws we removed behind the door and at the top. Now we're grabbing the console and setting it down in place. We're also guiding the wires through the top plate and pushing the console into place. Then we're going to take a picture of how the wires are connected before removing them. After we've done that, we can grab our Phillips screwdriver and remove the screw at the front of the main control. Once that's out, we're sliding the control to the front of the housing and pulling it away. Here's the old main PCB. This particular one is no longer available, but the replacement process is the same across many models that use a similar control. We need to slide the main control into place on the housing and then secure it with the Phillips screw. Once we've done that, we can reconnect the wires. Then we can use our Phillips screwdriver to rotate the main control back in place and secure it with the 3 Phillips screws that we removed earlier. Now we're grabbing our top panel, setting it on the dryer about 3 inches or so from the console, and then sliding it forward. We need to secure the top panel with the final Phillips screws, and with that, we're all done. Don't forget to plug the power cord back in or turn that breaker back on. Did you find the faulty part? Whether it's the main PCB or something else, all you have to do is get your model number and head over to appliancepartspros.com to get a replacement. Most orders arrive in just 1 or 2 days, plus we'll be here if you need some help installing it. We'd love to hear about your repair experience, so let us know how it went by leaving a comment below. Thanks for watching, and we'll see you later.